So how do we graph this piecewise find function? So these are the domains here, and this is where this is what tells us when to use each piece. So this is a constant function, y equals -1, a horizontal line, and we're going to use that one from when x is less than or equal to -2. So something I'll do when I'm graphing these is I'll put the dividing lines in, and my dividing line for this piece is at -2. And my dividing line for the other piece is at +1. So I'll put those in there just to help give myself a visual on how to keep these separate. So the other thing I'm noticing is that this is equals to also. So it includes. So when x equals -2, I'm using this part of that function. So that tells me I'm going to have a filled-in dot at for -1. So let's see it, -2, -1. So there, I've got that filled in dot, and then it's just a horizontal line, and I shade it to the left. Now I get to graph the second part, and that I'm supposed to use between -2 and 2, and it's going to be an open circle when x equals -2. So when I'm graphing a y equals mx plus b line, of course, I start where the y-intercept is 1, and then I'm gonna go up 1, right 1, and that puts me on +1 when x equals +1, and that's included. So I'm gonna have a filled-in dot there, and then I go down 1, left 1, down 1, left 1, and technically this is supposed to be open here, but because it was already filled in, I think we can just leave it filled in. Now on WebAssign, which you should do, on My Open Math, what's been working this last week when I was doing this is do the filled in dot for the -1 and then do an open dot right on top of it, and it seems to be working. They seem to be taking the answers. And then the last piece, when x is greater than 1, we use y equals 0. So open circle at 1, and I shade to the right. That's the line y equals 0. Okay, and that's that piecewise defined function graph. And I figured since I'm recording a video, might as well do a couple more out of the book. So for this one, let's see, I'm using the absolute value function when x is less than 2. So here's my dividing line. There's only one dividing line here. Let's see, when x is less than 2, I'm supposed to be using the absolute value graph. Well, the absolute value graph is just, that v that's centered at the origin. So it would start, let's see, I'm going to go with my pointer. So my vertex is there, then I go up 1, left 1, up 1, left 1, and then this is where I'm actually supposed to be graphing. So I'm going to put an open circle there because it doesn't include x equals 2, and then I'm going to go up 1 over 1. Basically, it looks like the line y equals -x. Then to the right of 2, I use the graph y equals 5. So my scale's a little off. So that's going to be a horizontal line. It's filled in at x equals 2, and then I shade it to the right. Or graph it to the right. And that's a function because it passes the vertical line test. There's only one y for that x equals 2. It's not continuous, and that's another whole thing to worry about, but not this year. Another graph just like the one on WebAssign. So let's draw this. -2, +1. I encourage you to look in the book exercises, folks. People sometimes just look at the graded WebAssign stuff, but the practice is in the book, and you get the worked out answers. So especially if something's giving you a hard time. So I'm seeing a horizontal line y equals 3 when x is less than or equal to -2. So let's see, so filled in horizontal line to the left. Then I get this y equals mx plus b equation, which is +1 is the y-intercept, and then I'm going to go down 1, right 1, and I'm going to go up 1, left 1, up 1, left 1, and that's technically an open point there, but since it's already filled in. So there's that graph. and then y equals 3 back when x is greater than 1. So we're back to this piece over here. And let's see, that's open and to the right. So I hope that helps you graph these piecewise defined functions.